All right, everybody. Miss Anderson, science class. If you've not realized, we're starting new material. It is going to be Thursday, April the 23rd. Today, we're going to be talking about plate boundaries. And instead of me just giving you the Nearpod lesson, I'm going to walk you through it like I was actually in the classroom. So, the first thing I want you to do is get a blank sheet of paper. I honestly do not care. It could be printer paper. It can be notebook paper. I don't care what kind of paper it is. All right, when you get this piece of paper, you're going to follow me to learn how to fold it. All right? All right, so I got my paper. I'm going to fold it in half. Once I fold it in half, excuse me if I already folded it, I'm going to fold it into one square. So you see how you have this long piece of printer paper that's folded in half. I'm going to take my right hand and I'm going to fold that in just like that, and I'm going to crease it. Then I'm going to flip it over and I'm going to bend it forward. I'm going to fold it again and I'm going to crease it. When you're done, you should have 6 different cubes or 6 different squares. These 6 squares we're going to use when we're taking our notes. All right, so the next thing that you're going to do is log into Nearpod. I put the code and the link in your Google Classroom, so I want you to go ahead and log into that. And then we are actually going to do a lesson together. So you're going to follow along with me like we're in the classroom. All right, everybody, we're learning about plate boundaries, so follow along with me. All right, 2 types of crust. You have oceanic crust and you have continental crust. Your oceanic crust, and the reason why it says brown is because you can color that brown if you would like on your squares and the notes that we're going to take in a few minutes. All right, so the oceanic crust is 5 kilometers thick and is made of a dense rock called basalt. And then your continental crust, you can color that black if you please, is 30 kilometers thick and made of a less dense rock called granite. Now, less dense. What does that mean? What does less dense mean? Now you have to go back to the last thing we did before we left for pandemic break, and that was our density lab. So I want you to think about that. We'll come back to that at the end of the lesson. So in your first slide on the squares that you created, you're going to put 2 types of crust, and then you're going to put the information that you see here on the screen, like so. All right, as you see, I have the first slide of Nearpod all right here. The 2 types of crust, oceanic, continental, and I have the drawing that we did. So every time we go over to a new slide, I want you to follow along with the notes and put each slide in a box. If you feel like you need more room and you need another box, feel free to continue into the next box. I'm perfectly okay with that. And then you still have the back. So if you need to roll over to the back, you may. All right, so let's keep going. All right, so the second type of plate boundary we have is called a divergent boundary. So this one is an ocean to ocean divergent boundary. So what you see is you have 2 different plates and they are of the same type of crust, oceanic crust, and they're moving in the opposite direction from one another. And you have a submarine mountain range is created, so that's what this is. You can have volcanic flow happen at these type of boundaries. You have earthquakes that can happen at these type of boundaries. There is new seafloor created. So I want you to remember that when you see a boundary and it's divergent and it is ocean to ocean, it's going to go in the opposite direction of each other and new seafloor is going to be created. Because what is happening here is magma is going to come up When magma comes up, it's going to cool. Once it cools, it's going to create new seafloor. So an example of this area would be the Mid-Atlantic Ridge. Right. So we have another divergent boundary. And what did I tell you divergent meant? Opposite directions. So this time you're looking at continent to continent. So that's two continental crusts that are moving in the opposite direction of each other. So what is created when this happens? You have a rift valley created. Sometimes it fills in with water. It's a shallow earthquake can happen in this area. And the two examples of this is the East African Rift and the Red Sea. So again, make sure that you're following along with your squares on your piece of paper. You're going to draw this diagram. Make sure you have these 3 bullet points in your example. And remember, this is continent to continent. So this is opening up. This is land. This is land. And water is going to be able to rush through here because there's a separation at this point. All right, everybody. So we have our transform boundary. And this boundary we're going to talk about is a continental transform boundary. You have 2 plates that slide past one another. So I want you to remember this. They're sliding past one another. Okay? They're not going up underneath one another. Oh, where's my camera? All right, here I am. They're not going up underneath one another. They're not going in the opposite direction of one another. They're sliding past each other like so. Sliding past each other. There we go. They're sliding past each other just like that. So that's the best way for me to give you a visual of how these plate boundaries are moving. One is going in this, one is going up, the other is going back. They're just sliding past each other like this. When that happens, what is created are earthquakes and fault lines. No volcanoes will happen in this area. No volcanoes, all right? And an example of this is the San Andreas Fault in California. Later on, I will give you some videos showing you the actual effect of the San Andreas Fault on California. If you've ever been to California, maybe you've heard about this. All right, so now we have a mixture of crust and these convergent boundaries. You'll have an oceanic crust, which is what you see here. See the water and the oceanic crust, and you'll have a continental crust. And these two areas are going to bump heads. They're converging, they're meeting each other. So remember earlier when I said, keep in mind about the oceanic crust is more dense. What does density mean? If you still don't remember, look at this picture. If it's more dense, what's going to happen? It's going to sink. Remember when we did our layers, when we were in our density lab in class, and the heaviest layer was at the bottom, and the lightest layer of salt water was at the top. And the way we were able to differentiate this was with the food coloring that I put in each different jar of salt water. So what are the effects of these convergent boundaries? Well, your earthquakes will happen. You'll have an ocean trench right off the shore, and that'll be up in this area. You can have volcanic eruptions a few miles inside of the continental crust. So all of this going on is going to cause volcanic eruptions up on the crust. And then an example of this would be the Cascade volcanoes in the Andes Mountains. I encourage you to look up these examples so that you can get a visual. If you have any free time, just Google it, Cascade volcanoes, Andes Mountains, and then come back and look at this slide or go back and look at your notes and compare. Oh, so this is what's happening there. All right, let's go on to the next slide. So we have another converging boundary, which means we're bumping, we're going head to head. And this time it's going to be ocean to ocean. And when you get an ocean to ocean convergent boundary, you're going to see some similar things going on. You're going to see that you have earthquakes, but these earthquakes are going to be a lot stronger and a lot deeper. You're going to still have your ocean trenches. You're going to see a chain of volcanoes. And it's going to be a destruction of the oceanic plate. So it's going to rip them apart. It's going to tear them apart. It's destructing them. And some examples of this is like the Caribbean Arc and other examples you can find online. I want you to take your time. I want you to slowly draw these pictures out. If you have coloring pencils, if you have markers, go ahead and use them. Let's move over to the next slide. Let's see what the next boundary is. Oh, and at any point in time, you need to pause so that you can fill in your notes, draw your diagrams accurately. Please feel free. All right, next, convergent boundary again. What does convergent mean? What did I tell you? Bumping heads. So this vocabulary, get this vocabulary in your mind. A convergent boundary, continent to continent this time. So you have two continental crusts. Where do we live on? Do we live in the water? No, we live on the continental crust. So this is where we're going to see our earthquakes. We're going to feel them. Then this is where mountains are formed. There's going to be folding of the land. And I'll go over folds and faults sometime next week so you can understand what I mean about folding of the land. I know you're thinking like, wow, how can the Earth's crust fold? Wondering about that, huh? It can fold, and I will show you next week. Example of this is the Himalayan mountains. All right, everybody, that's it. That's the Nearpod lesson for the day. I want you to make sure that your notes are complete. They're completely filled in. They're nice and pretty. If you have, like I said, if you have color pencils, markers, feel free to draw, anything like that. If you have any questions, please let me know. Go ahead, rewind this as many times as you need to get a full picture or understanding and clarity of these plate boundaries. Listen to this as many times as possible. Okay, everybody. So the last slide is a flip grid. What I want you to do is go ahead and log in. Yours will not say sixth period unless you're in sixth period, but I decided to use sixth period's slideshow for today to do our lesson. So go ahead and you should be able to log in with Google. It'll take you over to Flipgrid. And when you get to Flipgrid, what I want you to do is show me a picture. Like you can see mine. Show me a picture of your notes. Then I want you to describe two different types of plate boundaries. So you're going to choose what type of plate boundaries you're going to describe. Divergent, ocean to ocean. Divergent, continent to continent. You tell me. You get to choose. I want to hear what you have to say. And the last thing I want you to do is explain to me how density affects plate boundaries. So again, go back to the slide where you see that we're talking about density and plate boundaries. I want you to explain that to me in our own words. And you are allowed to refer back to our density lab to give further examples if you need to help explain yourself. All right, have a wonderful day. See you tomorrow.